Setting up, we'll go ahead and get started with an introduction. Anthony Grescavage is from Nodeology. He's a principal consultant. He specializes in GIS technology and system architecture and GIS software engineering with an emphasis on process design and automation. Anthony was first introduced to GIS while serving in the Army as a topographic analyst. Upon leaving the Army, Anthony provided GIS services while employed at companies in numerous industries, including BAE Systems, Williams, Stahl Schaefer Engineering, and Development Faction, a GIS consulting firm. Anthony's work has previously been featured at EnerGIS in 2013 in a presentation titled Integrating HD GPS Video-Enabled Video Playback with Web-Enabled GIS to Analyze Pavement Defects for Oil and Gas, as presented by Matthew Smith and the late Aaron Fish. Anthony was the lead system designer and software engineer responsible for designing roadway management and engineering technology that helped revolutionize engineering options in oil and gas. Anthony's goal is to drive innovation, automation, and efficiency in the geospatial technology across the industries.
A longer introduction than I expected. And he didn't even mention the most important detail, which is that I've been mountain biking in Baghdad. That's a claim to fame, and it's one thing that as far as I know, only two other people have ever done, and it's the two other people were the one riding with me in Baghdad.
So are we changing it to call it?
It works for me. All right, so a little bit more on my background. I'm jumping ahead here. A little bit more on my background. He mentioned ties to EnerGIS. I was with Matt Smith and Scott Wiegand at Development Faction in the early 2000s. And as Mark mentioned earlier, Matt Smith was instrumental in getting EnerGIS launched. So as far as EnerGIS is concerned, I like to think of myself as Uncle Tony. Yeah. I wasn't there to make it happen, but I was on the side the whole time. All right. So I'm going to skip through the intro to Nodeology. I think we covered all that there. So I think the big question is, what is geospatially enabled video? And if you were able to go back all the way to the presentation in 2013, what you'd see is it's effectively just video with a corresponding path and playback location on the map. It's really as simple as that. So let me see if I could get the video to play properly. This basically sums it up. Those of you who are native to Pittsburgh probably recognize this nightmare on the right. That is the Squirrel Hill Tunnel, and we're getting a nice little tour through the tunnel. And you can see as it drives along, this actually happens to be, I think, most or all of my videos in this demo happen to be 360 videos. So as you can see, when the car is driving through the tunnel, probably a lot faster than you would normally expect in that tunnel, but you're able to see the location on the map, and of course, in this case, turn around and look back at the tunnel. So some history of the technology. This technology was originally developed in the neighborhood of 2010, 2011 on Microsoft's old Silverlight platform, which is long gone away. I was actually a little bit depressed when that went away. It was some nice technology. But it was developed largely for roadway management purposes. Now, one of the things that we encountered when we were first introducing this technology for roadway management was that at the time, a lot of organizations, when they were doing roadway management, they were doing road inspections, they were using, those of you who have been around long enough to remember the arc pads, they were using arc pads, they were using survey sticks, in potholes to mark the locations of roadway defects. Obviously, that's horribly inefficient, but they were getting caught up in the accuracy concerns that are typical with surveyors and engineers. And what I mean by that, when you ask them, say, what level of accuracy do they need? And they say, how much could you, what's the best you could do? And what we ended up doing was saying, effectively, tell me why you need a certain level of accuracy for a pothole. Tell me why you need a certain level of accuracy for a defect, for a roadway defect. And what we came to find out was they really didn't. They really, when it comes to certain types of features, you need a high level of accuracy. There's a lot of things you need to use LiDAR for. You need a LiDAR scanner and mark the location of something with a high level of accuracy. A hole in a road isn't one of them. And there's a lot of other cases like that. I mean, if you can't get your engineers out there to figure it out where it is and patch a hole based on, a video and some GPS data, then, they need some retraining. So the tool was originally integrated as part of a roadway management application back in the early 2010s and demonstrated at EnerGIS 2013 as part of the integrating HD GPS video application. All right, so, of course, why video? Why in the era of LiDAR, digital twins, and all of this other stuff, why video? And that's really it. It's fast, it's cheap, it's efficient, and it's the tool you have. And when I say it's the tool you have, my props here are up here for a purpose. Now this here camera, this will run you, this is the Insta360 Pro 2. That'll run you about 5K. If you were to step it up a little bit to the Insta360 Titan, you could spend 15. If you went up to some of the Mosaic cameras, Mosaic 51 will set you back somewhere between 30 and 40 grand. Mosaic Viking will set you somewhere in the neighborhood of 50 to 60. This will set you back about 400 bucks. And likewise, this here is the GoPro Max, somewhere in the neighborhood of $400. And this is the GoPro Hero 11. I think I paid $350 for that. So this is mostly as a decoy here today because this spends most of its time in the case. I use this far more than anything. And part of the reason for that is because if I'm going through sticks, if I'm going anywhere where something's going to potentially happen, I don't want to smack this up against a tree, but I don't really mind doing that with this. And this will get you probably 70% of the way to where that's going to get you. All right, so some of the benefits that you'll see from using video, GPS-enabled video for data collection and engineering applications, you're going to increase speed. One of the things, tying this back to the military, one of the things that you learn in the military is to make use of the resources that you have available quickly. People, you think about getting intel, and you could talk about reconnaissance drones and all these other things, but sometimes getting the information means sending the guy to the top of the hill and have him, just have somebody on foot go in and take a look. It's a whole lot easier to deploy something like this than it is to deploy a large vehicle-based LiDAR system, a drone, an airplane, and everything like that. There are cases where you just really need to get something out there, collect the data, and see what's there, and come back and deal with that information back at the office. For costs, one of the things we've encountered over the years is that if you could some sort of visual data, it reduces the need for you to send higher skilled personnel out to the field. If you've got an intern and you've got an engineer, if it's something where you don't have the ability to bring data back quickly and easily, you'll probably have to send the engineer out there to take a look. If you have the ability to, strap something like this on the top of a vehicle, you could send an intern and say, drive a loop around that street, come back and bring me the data. And it's going to save you time. It saves you time and money on your field personnel and your equipment. And of course, accurately document conditions. Now there's a lot of different, as I've said, a lot of different applications for LiDAR. But when you're looking at 360 video, 2D video, whatever type of video it is, it's a picture. Everybody knows how to look at a picture. Not everybody knows how to look at, LiDAR data. So if what you're trying to do is come back with something that's quick, that can be digested quickly, easily, and cheaply, this is often a good solution. So some use cases, we already talked about roadway management. For what roadway management, over the years, it's been used for everything from road surface conditions, just about everything else within roadway management, asset management. For a lot of these things, what you'll see is the most applicable situation is when you have some sort of long linear feature, whether it's a roadway, a pipeline, or perhaps a hurricane down on the west coast of Florida. Often you need to capture that data quickly, get eyes on, and get out. And in those cases, that's where you'll find the video is most valuable. All right, so an example here for infrastructure, electrical infrastructure inspection. So this is an interesting one. Let's see if the video's, okay, it's playing. So this is 819 out here in Westmoreland County. And as it's driving along, I can't tell how bright that is over here. Okay. Now, I don't know who owns these lines out here, but basically half of the lines between Greensburg and Salem Township in Westmoreland County have trees laying on them like that. And when I say there are cases where LiDAR makes sense and there's cases where it's not needed, you don't need LiDAR to see that's wrong. Somebody doesn't need LiDAR to see that that's a problem. So it's very easy to be able to review the video and go along and look at those lines and see when something is out of sorts along the side of the road. Okay, so roadway management. This is a similar application with windshield videos. I don't know if I hit the play button or not. There we go. All right, so this is a classic windshield survey video. This here is on Athena Drive in Westmoreland County. So we're going to be driving along the road here. And as it's going to come up on some, this particular video is actually taken with the GoPro Hero 11, which for, when you're looking for road surface videos or something where you're looking to collect a high level of detail in one specific direction, this is actually one of the best cameras you could buy. And the reason for that is even the cameras that are 10 times better than anything on this shelf here generally don't have the shutter speed designed to capture high speed video the way these things are. These are primarily designed for extreme sports, mountain biking, and a lot of different things like that. And coincidentally, they make them ideally suited to be able to capture the detail, even when you're doing upwards of, say, 25 to 35 miles per hour in a car. Now, I'm not sure, we probably won't be able to see it, but as the car, I think it's still a good ways away. But somewhere down near the end, I'm going to see if I could pause it as it's coming up. It's going to come over the hill, and there's going to be a nice little detail at the end of the road here. Now these, I don't think I've done it yet, but if I haven't done it, the video you can also change the speed of the video to be able to review it at a higher speed if you're looking to get a quicker view of the data. So some point up here, it's going to change to a higher speed and go to the end of the road in a bit of a hurry. And I'm going to try and catch it right before it gets there. Okay, so that is slow motion, so that during this section, it's going to give you can see on the left, and then coming up here on the right, you get a really nice view of the current roadway conditions. And quite often, while it's certainly possible to extract defect features using the information that you're getting from these videos, I really appreciate some input from a friend of mine earlier when we were talking about how there generally isn't the need for that sort of thing in engineering. More than likely, you're just trying to get a rating for the roadway. And any good engineer is going to be able to look at this roadway and determine, exactly what the condition is of that roadway just based on the data in the video. Oh, and we skipped by it, right? We skipped by it. It was going a little bit too fast. But just for my fun, this little detail right here, that's a tire mark going off the side of the road. That's where my daughter's boyfriend decided it would be fun to drive his car off the road and hit a tree rather than hitting the deer. Everybody's fine, but he got an earful for that one. But that was a lot of work just to, show this trail. But this is on foot, and it's, it's kind of a little dark on that screen, but this is another area. If you look up there, right above the trail on the left there, you can see the power line that's actually sagging across the ridge. It's laying on the ground up there. But yeah, any video that has embedded GPS information, or even if you could fabricate the GPS, if you don't know exactly where you were, as long as you have the timing down right. A good example is the Squirrel Hill Tunnel. As soon as you hit the tunnel, it blows out the GPS. But if you're going through the tunnel, in this case, as I rode through the tunnel, I maintained a consistent speed through the tunnel, and then I'm able to just edit the GPS points, wipe out any of the bad data, and then it just interpolates from the last good point to the next good point coming through the tunnel to get your GPS data. But as any camera that embeds not just the single GPS point, but the GPS stream into the video, whether it's a cell phone, a GoPro, an Insta360, or one of those crazy, Mosaic Vikings. All right, questions? Yes, sir. Yes, actually, so there is a little that goes into that depending on the application, but for the 360 cameras, you're generally going to want to go slower. I would say 25 and below for the 360, but the action cameras you could generally go quite a bit faster. Like I think I probably could have gone faster with the GoPro Hero. It's you get to the point where once you start to get motion blur and you can't see the cracks in a road very well in that application. So I think it's going to depend, on this specific application and what you're looking to do. But even in some cases with the 360 cameras, what I'll often do is when I just keep an eye around, make sure to keep an eye on everything I'm looking at, as long as I know the context of what I'm looking at. If I understand the context of what I'm looking at, I'll drive a little faster in areas that aren't important. Like if it's power lines, if they all look pristine, I'm going through there 35, 45 miles an hour. Coming through some of those areas where there's trees all over everything, there were areas approaching some of those fallen trees, I slowed down to 15. I probably didn't need to, but want to get that extra quality in the data. So it's it's variable, but generally you could still cover a good bit of ground very quickly. Yeah. Yes. So the embedded player, in this case, it's YouTube. So the video itself, that is a YouTube player embedded in Experience Builder here.
My question was in terms of the roads where they assess, is there a way to use the sound profile to then match it in terms of, because I know when you showed this picture, driving down some of the road, it changes the sound based on how rough the road is in terms of just adding that with the number of data points and the quality of the data.
Yeah, what's funny is I typically will tend to strip the sound out for a lot of cases. And for my videos, I'll do quite a bit of editing in general. And I think that's probably something that would at least cause me to think about keeping the sound in. I know some of the videos, there's cases where I'll put the camera on the back facing down towards the ground and then drive, but then reverse the video, which looks really funny to people watching it because it looks like I'm going really fast in reverse. On the wrong side of the road, but yeah, that's an interesting point.
Because you have built kind of a correlation matrix of, if you look at the sound profile, the peaks and the valleys,
Yeah,
with then tracks and so forth, then you can kind of build like a better word, kind of a standard curve of sound profile and quality of the road.
yeah. I could see a good application for that if you actually extract the defects, to turn around and take the defects, the video with the sound, and feed that to AI and get some good, interesting output just based on that. That would be, you got me thinking. I'm sorry? Oh, so there's an interesting point to that, and I don't have the sound here, but when I first pull out on the first video, my car, I have a RAV4 Prime, so it's a plug-in hybrid, and the first part of the video sounds like a spaceship because of that, that artificial hum that it makes as it pulls out. But then it does go pretty much completely silent, which is, the only thing you can hear is wind noise. So. Any more questions? Sorry. Yes. I know. So I'm pretty sure both of these have one, and I know this has one. I've never really played with the data too much, but yeah, I know the data's in there. So. No. This is a custom widget that we developed for Experience Builder. The videos themselves are the paths are. It's just a feature layer that has the YouTube ID in this case, and the M values are the timestamps, which is what makes it easy to edit the video as necessary. If you need to, maybe something's off a little bit, you need to tweak a little time, you could just, adjust the M values if needed. And then of course like I said, the YouTube video on the right. So you could have, like in this case, there's two videos displayed. If you clicked on either one of those, it'll actually take you to the other video. It's just a feature layer.
I'm just gonna ask, are you selling it in the marketplace?
We are working on getting it listed in the marketplace.